All right, so the first question, it's looking at finding a vector from two given points. So I'll do question D, but you guys have to do 1A, B, and C. D is just repeating A to C with different values. So we have C is equal to -5, 7, 9, and D is 0, -5, 6. So we're looking to find the vector CD. The way we do that is we do final minus initial. So we're going to take point D. We're going to subtract point C. And to do this, you just subtract the like components. So 0 minus -5 will give us +5. -5 minus 7 will give us -12. And 6 minus 9 will give us -3. But then it also says in the question that he wants it in the form A1i plus A2j plus A2k. So if we do that, we'll have it in the form 5i minus 12j minus 3k. So for the next part, question B, we want to use that answer to write down 6CD and -5CD. So 6CD, we will just multiply by the constant. So 6 times 5i minus 12j minus 3k. And just multiply that number through. So it'll be 30i minus 72j minus 18k. Similarly, if we had -5 CD, -5, so -5 times our vector, which will be equal to -25i, 60j. So that's not too hard, really. And then for part C, we want to use the answer from part A to find the magnitude of the vector. So the magnitude is given by pretty much doing Pythagoras with each part as you would with two parts. So the magnitude of CD equals the square root of 5 squared plus -12 squared plus -3 squared, which comes up to the square root of 178, which is equal to about 13.115. If we move on to question 3, it's asking for us to find the angle between the two vectors A and B, and then using a formula, and then use that result to then find the angle in radians. So I do question 3A. We have A is equal to 2i plus j, and B equal to -i plus 3j. So what we want to do is, firstly, well, we've got this formula which he gives us in the question. Cosine of the angle equals the dot product of A and B over magnitude of A times the magnitude of B. So if we're doing the dot product, the way that I write this is I change it into the form where we get rid of the i's and j's. So we have 2 and 1 dotted with -1 and 3. And the dot product is simply multiplying the, if you like, I terms with each other and adding it to the multiple of the j term. So this will be equal to 2 times -1 plus 1 times 3. Right, so 2 times -1, and then we're adding 1 times 3, which will be equal to -2 plus 3, which is just equal to 1. In your question, you have to do, you actually have 3 terms. You have I, J, and K, but it's the same thing. You just have whatever the K term is here multiplied by the K term there. Yeah. But for this one, so that's the dot product of A and B, and then we also need the magnitude of A and the magnitude of B. So the magnitude of A will be equal to square root of 2 squared plus 1 squared, to be equal to square root of 5, and the magnitude of B will be equal to square root of 1 squared plus 3 squared, which equals the square root of 10. So from that formula that he gave us, we've got the dot product, we've got the magnitude of A, and we've got the magnitude of B. We can substitute it in to get what cosine theta equals. So therefore, cosine theta equals the dot product of A and B, which was 1 over square root 5 times 10, which is equal to 0.141. And then putting that into our calculator, if we take theta, would be the inverse cosine value, which will come out at 1.429 radians. And that's really all it is. So the only difference with your question is that you'll have, like I said, three terms in here, but you just do the same thing as what we did for these terms. And then you'll also have a third term in the magnitude, but I did one of those on the first question. So that one should be sweet. If we look at 4b, we want to, he gives us a formula for the cross product, and then for the given vectors, calculate the cross product, the area, the parallelogram defined by the two vectors, and then the dot product of A, B, and B, C. So if we look at 4b, we have the two vectors. A is equal to 6i plus 4j minus k, and B equals 2i plus j plus 0k. So if we use this formula he gives us, is the cross product is equal to the determinant of this. So we can just substitute in our values. Give us that A cross B is equal to the determinant of I. Okay, that'll remain the same. And then if we're putting in our values, we'll have 6 here, 4 and -1, and we'll have 2, 1, and 0 for B based on these values. And then from there, it's just doing the determinant like you would a 3 by 3 matrix. So if you're not sure how to do that, then look back at determinants of matrices, but you'd end up with 0 minus -1 times I. Then we're going to subtract 0 minus -2 j, and then we'll add 6 minus 8 k. And if we simplify that, we'll get I minus 2j minus 2k. This minus here comes in if you review matrices and determinants, but obviously we have kind of a checkerboard, right? So plus, minus, plus. So that's where that minus comes from. So that's the cross product. You've done the first part there. But the second part of that question is to find the area of the parallelogram defined by that. And if you look at the notes, the area of the parallelogram can be found by finding the magnitude of A cross B, which will be equal to square root of 1 squared, 2 squared plus 2 squared, which comes out to the square root of 9, which is equal to 3. So that's the area for that. And then he also says to find the dot products A dot C and B dot C. So from what we had at the start, A was 6, 4, and -1. And C we found to be 1, -2, and -2. So then if we do the dot product, right, we're going to have 6 times 1 4 times -2 plus -1 times -2. So 6 minus 8 plus 2 is going to come out to 0. And similarly for the dot product of B and C, we'll end up with 2, 1, 0. 2 times 1 will be 2, 1 times -2 will be -2, and then 0 times -2 will be 0. So what you'll notice in that taking the dot product of these, you get 0, which you should do if you take the dot product of your original vectors with the cross product, right? So that's what we had here. This is the cross product. Right, if we write that, we have 1, -2, -2. In that form, which is what I use for C. So that's our cross product. And you can see that when we dot product the cross product, which is C, with the original vectors we had of A and B, we get 0 in both cases. And the way that that works is because if you look at the formula, cosine theta is equal to the dot product of A and B over magnitude of A, magnitude of B. So by finding the cross product of the two vectors, that's a vector that's 90 degrees to the other two. So therefore, cosine of 90 will give us a 0 equals A dot B over the magnitude of A over the magnitude of B. If this is going to be equal to 0, then this part has to be equal to 0, right? Because we can't, obviously, it can't be dividing by 0. That doesn't work. So this has to be equal to 0. So that's what we've proved with what we've done here. So if you don't get the 0, you've done something wrong somewhere, either in calculating your cross product or in doing the dot product calculation. So that is all there is for the assignment questions, but I will go over a couple of parameter vector equations of lines. So if we look at question 6a, we want to find the equation of the line that's through point A and parallel to B. So he gives us that A equals 3, 4, 2. And the vector B 3j plus 2k. So if you look at the notes, he has a bit of a formula where he says P is equal to A plus lambda B. So A is a point and B is a directional vector and lambda is some scaling factor, right? So to determine how long that line is. So our A will be this here because it's a point, and our directional vector will be the components of this, because it says it's in the question that it's the line that we want is parallel to B. So if they're parallel, we'll have the same directional vector. So therefore, P will be equal to 3, 4, -2 plus lambda times I plus 3j plus 2k. And then if we do it so that we have it in the same format as what he has in the notes, we'll end up with 3 plus lambda I. So the way I've done that is that this is the I component of the point. This is a plus here. And what we have here is a 1i, right, pretty much. So if we have 1 times lambda, you can factorize that out. So I have 3 plus 1 lambda, 3 plus lambda I, plus 4 plus 3 lambda j, right? Same thing, we've got a 4 here. We've got 3 times lambda there, and then the j, and then plus -2 plus 2 lambda, and that should have a k in there. Yep. So that's in the format here in the notes, like that. You can also do it if he gives you 2 points. So question 7a, he gives 2 points rather than a point and a directional vector for you to use. So we have point A is equal to that, and point C is equal to 3, 4, 5. So we need to find the directional vector, but we can do that by, we can find the vector AC by taking point C, subtracting point A, right, like we did in question 1. Just subtract the components, so 3 minus 2 will be 1, 4 minus 2 will be 2, 5 minus 1 will be 4. So that's our directional vector, which we can write in the form I plus 2j plus 4k. So therefore, P will be equal to, like we had before, our point, which will be 2, 2, 1, plus the directional vector times lambda, so we I plus 2j, which will come out as 2 plus lambda. I plus 2 plus 2 lambda j plus 1 plus 4 lambda. Okay. And that's really all there is to it.